class 3 of electrostatics conductors. Now you have a thick spherical conductor. Notice that the internal radius is, say, some r. The external radius is 2r. Till now, we were discussing about a cases where the charge is exactly at the center of the cavity. Likewise, that's what we were discussing till now. For a change, I will take a situation where at this distance is r by 2. And I have a charge q placed here. What is the arrangement that I am discussing is the charge is not exactly at the center of the cavity. Charge is not at the center of spherical conductor. Now, what is the consequences of this inner induced charge? Inner induced charge is non-uniform. Inner induced charge is non-uniform. Outer induced charge is uniform. That you should ask. I hope there is no ambiguity in understanding this particular part. And you know why the inner distribution is non-uniform? Because that is not symmetrically placed. Right. Now, for my understanding, I will define C as the center of the shell. And I require some points. I will say that this is point some P1 and this is some point P2 for my convenience. Please try to understand. Here what is happening is that as I mentioned, this is plus Q. I don't see like that here. You can see that right hand side more concentrated, left hand side widely spread. Whereas here it is uniformly distributed. Right. Now the question is whether you choose P1 or whether you choose P2. I told you very clearly the combination Q, point charge Q, and its induced negative charge on the inner edge of the cavity contributes nothing. Now tell me what is Vp1 or what is Vp2? It is as same as simply a point inside a charged spherical shell whose radius is 2r. So therefore, I will write this as KQ by 2 capital R. Right. So what is the potential at C? What are contributing potentials at C? V due to point charge, induced charge. Can someone please help me in writing what is VQ? KQ by R by 2 minus KQ by R plus KQ by any doubts? Any doubts? You are asking me the potential at C. I am just giving you the same. So therefore, this will become KQ by R plus KQ by 2R. This will be 3KQ by C capital. Any doubt in this? Yeah, please ask me. Very good question. I am finding the potential due to minus Q at which point? Which point? No, at center, right? Right. That point is equidistant from every negative charge on the inner edge. So minus KQ by R. Any doubt on this? Right. Now the question is, find field due to cavity surface charges at a point in metal matrix, the exact term. What is metal matrix? The thick part of the material. Very close to point P2 or point P1. Makes no difference. You are asking, or you are selecting the point in the metal matrix. Boys and girls, in the metal matrix. In one word, what should be your answer? In one word, what should be your answer? In one word, what should be your answer? Ante em cheppali? Find field due to the cavity surface charges. Zero. Right. నేను అన్నది అదే. At that point అన్నా, నేను ఎవరి వల్ల నేను మాట్లాడలేదే. క్వశ్చన్ లో క్యావిటీ అన్నారు, నేనేమని అడిగాను? పాయింట్ దగ్గర ఫీల్డ్ ఎంత అని అడిగాను. జీరో. At P2, E net is equal to 0. EQ bar plus E minus Q cavity bar is equal to 0. Boys and girls, let us define a unit vector n cap in that direction along P2C. N cap is along P to 6. So therefore, E minus Q cap is minus E Q cap Q bar minus 1 by 4 pi epsilon naught Q by R plus R by 2 whole square. Which direction? Negative charge. No. That is due to positive charge. Heavy. Any doubt, boys? That is due to a point charge. That's how the direction of the field is. Opposite way. Minus up minus plus. ఇప్పుడు మీరు ఏం రాస్తారు ఓవరాల్ గా దీన్ని ఏం రాస్తారు ఓకే 1 by 4 pi epsilon అన్నది అవసరమా రాయటం నో minus 4 by minus కాదు 4 by 9 kq by r square. Any doubt? సో ఇప్పటి నుంచి ఆలోచించాల్సిందే anytime if they are asking cavity alone, whether it is necessary or not, bring the point charge and the charge distributed on cavity together. Sahasravai. క్యావిటీలో ఉన్న పాయింట్ చార్జ్ ప్లస్ క్యావిటీలో ఇండ్యూస్ అయిన నెగటివ్ చార్జ్ టుగెదర్ కాంట్రిబ్యూట్స్ జీరో ఫీల్డ్ అవుట్ సైడ్ దట్ సిస్టమ్. Any doubts? No, I already have given a written format only last class. Cavity plus the point charge together contributes zero potential, zero field in the metal matrix. Okay?
Here also you took out. Here also due to cavity it will be zero.
No.
But here also due to cavity means everything inside that will be considered. Induced plus point charge.
वही zero बोल रहा हूँ. The combination gives zero, not cavity alone, or not the point charge alone. Yeah. One more question, which is a bit debatable. Now I'm giving you that question. Find the potential at P1 due to contribution of cavity surface charges tell me how. You set the point P1. Already we have determined at point P1 potential is KQ by 2R. We already know. We already know this. What do you want? See, my point is very clear. V cavity, V point charge, V outer surface is KQ by 2R. You know this. They are saying, నన్ను అన్నెసరిగా రాయిస్తున్నారు కానీ దేర్ కాంబినేషన్ ఇస్ 0 అని అరిసి చెప్తున్నారు. డ్యూ టు V point charge, I told you already this point. Remember, this is the fundamental question which I might question you repeatedly hereafter. There is a question linked with this, and the same question linked with them, just extending the concept. A thin conducting shell which has total charge plus Q. Another point charge Q is placed at P such that Cp is 2R. Find diagram anyone. A point charge can induce charge on a conductor, but a free charge on a conductor cannot induce charge on a point charge. You know this. This is a thin conducting shell. What do you want? I selected intentionally a point E. What is the potential at E? Due to the point charge at B. You may ask me, what is this distance? This distance is R by 2. Listen to my question very carefully. What is the potential at A due to point charge alone at B? అందులో ఆలోచించేదే ఉంది. మామూలు ఫార్ములా మనం 1/4πε0 చార్జ్ బై డిస్టెన్స్. పిచ్చి క్వశ్చన్లు అడగకున్నాను. ఎందుకు జరుగుతుందా అసలు ఆ లైన్స్ నీకు ఎందుకురా అటు అడిగింది అంటే దానివల్ల ఇక్కడ పొటెన్షియల్ ఎంత వెళ్తాయో ఇదే అడ్జస్ట్ చేస్తుందో నీకు తెలుసా? రీడిస్ట్రిబ్యూషన్ జరగటం వల్ల ఏమైనా జరుగుతుందేమో. నువ్వు నెట్ ఎఫెక్ట్ తీసుకుంటే ఏముండదు, ఓన్లీ డ్యూ టు 1 అన్నప్పుడు 2R plus R by 2. This is 2K cube by 5R. ఓకే, ఇప్పుడు నీ ఫీలింగ్ హర్ట్ చేయకుండా ఇది చెప్పు. వాట్ ఈస్ ద టోటల్ పొటెన్షియల్ ఎట్ ఏ? చాలా తెలివిగా చెప్పచ్చు మీరు. నేను చాలా సార్లు మీకు చెప్పాను. I told you n number of times. Just now also I told. ఎట్లా 3/2 KQ/R కరెక్ట్. ఎట్లా ఎందుకు ఉంటుంది? షెల్ లోపల పాయింట్ కాబట్టి అలా చెప్తావు, రైట్? కరెక్ట్. అసలు ఫస్ట్ ఆఫ్ ఆల్ అందులో ఛార్జే లేదు కదా, లోపల ఛార్జ్ లేదు. ఇట్స్ ఈక్వి పొటెన్షియల్. సో కాబట్టి వాట్ ఈస్ కంఫర్టబుల్ ఫర్ us to find is to find the potential at C. Potential at A, for the total potential at A is same as potential at, which is KQ/R, KQ/2R. What is this called? Due to surface charge on shell. This one due to point charge. Any doubts? I'm asking again. Do you have any doubts? Right now, when you are listening, you will be very comfortable. For this, we are repeatedly asking all these things likewise. But when you are applying in the exam, small twists, you will totally fail. Do not compromise. Learn properly. No compromise. Go on. Any doubts? Clear? Right. ఇప్పుడు ట్విస్ట్. రాసేస్తాలే. How to find this? Why? Potential at A due to surface charges is it is the same as 3KQ/2R minus, I'm using this part. I'm using the left hand side part, the right hand part. And that is a Why 2KQ/5R?
It's the combination of point charge plus shell.
Due to point charge, it is minus KQ/5R/2. Antena? Correct? So therefore, this is 3KQ/2 minus 2KQ/5R. So yatavadi ఏమవుతుంది? 15 minus 4, 11 KQ/10R. Any doubts? Sure. See. Yes.
If that is the case, sir, the
potential at A due to only surface charges.
not this. I am saying you say total potential at A equal to total potential at C. It means, sir, they are equal potential. No? So if due to point charge on C, what potential should be there? That should also be on A. No, sir.
Alone due to point charge is wrong. Due to all distributions, it is correct. समझ गए ना?
పాయింట్స్ ఆర్ క్లియర్ దాన్ని అనుకోవాలంటే మొత్తం ఆ షెల్ లేకుండా చేసుకుని చేయొచ్చు షెల్ లేదు జస్ట్ ఆ పాయింట్ చార్జ్ ఉంది అలా చేసుకుని చేయొచ్చు
అంతేగా అప్పుడు ఓన్లీ డ్యూ టు పాయింట్ చార్జ్ అంతే
కొంచెం లాజిక్
లాజిక్ ఏం కదా నాన్న వాట్ ఈస్ యువర్ ప్రాబ్లం యు ఆర్ సీయింగ్ ద నెట్ ఎఫెక్ట్ బట్ యూ డోంట్ నో వాట్ ఈస్ హ్యాపెనింగ్ దేర్ వాట్ ఆర్ ద ఫండమెంటల్ కాంట్రిబ్యూషన్స్ దట్ యూ షుడ్ గో విత్
టోటల్ పొటెన్షియల్ అర్థమైంది దట్ ఈస్ ఈక్వల్ టు
అది కాదు అది అసలు చేస్తుందా లేదా నీకెందుకు నీకెట్ట తెలుస్తుందా కాదు కాదు కులూమ్స్ లా చెప్పేటప్పుడు మీడియం ప్రస్తావన ఏమైనా చెప్పారా కులూమ్స్ నో నో when you are placing a medium and you are speaking potential or field at a point, you are speaking about the net effect considering all other factors. Otherwise, under Coulomb'ian conditions, that is the force, that is the potential. Right. So I have done. Earthening I have done. Very good question. See, the purpose of this drawing is a conductor might pass through that, but it is not in electrical contact with the intermediate shell. This is a system of concentric shells. The switch is closed. Can you please help me? What? Let us label this as A, B, C. When the switch is closed, what is happening? That is okay.
Potential of the both cells become equal.
Yes. Finally, once this happens, no charge distribution takes place. How? Charge is conserved. Sohan, can you please help me in writing VA?
Inside into 4Q AQ1 by small plus 2KQ1 1 scale 4Q minus Q by 3.
So finally, what you have? Two by three minus one.
1 by 3. 1 by 3. 1 by 3. 1 minus 2 by 3.
Another question is, initial charge on A is final charge What happened? Tell me. So charge flown from minus 3Q by 2 from C to N.
No, it is 3Q by 2.
Array
3Q by 2 A to C.
A to C plus 3Q by 2.
Minus 3Q
Minus 3Q by 2 అన్నప్పుడు ఏం రాయాలి? Any doubts? ఫాలో అయినా మొత్తం చెరిపే సేమెంట్ చేస్తావా? పొటెన్షియల్ ఆఫ్ ఏ పొటెన్షియల్ ఆఫ్ బి ఎందుకు సేమ్? పొటెన్షియల్ ఆఫ్ ఏ పొటెన్షియల్ ఆఫ్ బి ఎందుకు సేమ్ అయినాయి? వింటున్నావు దొరకలే ఈసారి ఖర్చులో దొరుకుతుంది అదే నా బాధ. నెక్స్ట్ సో కాన్సన్ట్రేట్ లో మాక్సిమం మోడల్స్ నేను కవర్ చేసేసా. రైట్, now whatever that I am going to discuss right now, they are high end, so therefore you please follow very carefully. Already I have discussed this, but just see, initially only the inertial has charge plus Q. What happens? Q to induction minus Q plus Q. Now this is A, this is B. Net charge on B is 0. Any doubts? Now you have closed. What happens? This is plus Q. This is minus Q. 0. ఎర్త్ కనెక్ట్ చేస్తే అలా ఎర్త్ కనెక్ట్ చేస్తే it should be 0 potential. So outside any point, this one should act as a 0 potential. So for this to happen, as per Shell theorem, net charge must be 0 actually. జరగాలికి ఏం కావాలి? ప్లస్ కి వద్ద పోవాలి. ఇప్పుడు నాకు ఏమవుతుంది? వాట్ ఈస్ ద నెట్ చార్జ్? ఫైనల్లీ సుషా చెప్పు. నెట్ చార్జ్ on B era, this is equal to minus Q. ఇప్పుడు మీరు ఏం చెప్తారు? Charge minus Q flown from earth to P. This is one of the fundamental. Any doubt? Pakka? till last year, before last year, you see my notes as. Anyone have seen notes as last year, before last year? Already I posted this notes long back. Electrostatics of conductors notes I have posted long back, 1 week back. You will see completely different approach. Okay? So what I felt was that time students were following 3-4 days later, okay, next week format, total format. But to avoid that, now I am discussing everything in leisure, slow, from fundamentals. Any doubts? Follow. Yesterday you left off for IP preparation. Have you gone through? No. Right. Next. Now I am continuing this question carefully. Now this is the fundamental for my next case. An earthened shell in the near presence of a point charge. So what is that you are seeing is a thick conducting shell, radius r, this is given a charge plus q, plus q. What is that you are seeing is a conducting shell. It's a conducting shell. Having a net charge q. Can you see the net charge q there? All इसमें చూస్తున్నావా? క్వశ్చన్ అడిగితే చెప్తావా? ఇందాక మ్యాప్ క్వశ్చన్ సరిపోతున్నట్టు ఒకసారి కన్ఫర్మ్ చేయి. రైట్. అందరికి ప్లస్ క్యూ కనిపించిన షెల్ మీద. ఓకే, నీకు అనవసరం అది యూనిఫార్మ్ డిస్ట్రిబ్యూషన్ నాన్ యూనిఫార్మ్ డిస్ట్రిబ్యూషన్ ఇస్ నన్ ఆఫ్ యువర్ బిజినెస్. What is the net charge? Plus q. What is the point charge? Plus q. Did they connect it to earth? No. ఈ ఫీచర్స్ అన్ని మందాల్లో కూడా ఉన్నాయిగా. అడరా అనిరా నీకు ఉంటది. आप बोलो, will the charge on the surface be still capital Q? No idea, but I will say let this be. I don't know. Suppose if there is no flow of charge, ఏం చెప్తావు నిహారిక? క్యూ స్మాల్ క్యూ జీరో అంటావు, అంతే కదా. ఒకవేళ అదర్వైజ్ ఏదో చెప్తావు. రైట్, టెల్ మీ. కనెక్టెడ్ టు ఎర్త్. సి, అరే యార్ పైన వేసిన డయాగ్రామ్ కింద వేసిన డయాగ్రామ్ అడు కాదు, అదే కలర్స్ యూజ్ చేసిన చిన్న చేంజ్ ఈ క్లోజ్. టెల్ మీ. Can I ask a question? What is
Outer charge, it is only small q, not q plus small. Only small.
no? Total outer charge is now capital Q plus small q. Why I have written Q is that is the charge transfer from Earth onto the. Please tell me what is happening now. Potential of the cell will be 0 means potential at point C. Potential at C must be 0. KQ by Dara. KQ by 2 capital R. Assertion reason. When ideal cells are connected in parallel to an external load, the effective effective EMF increases. Parallel. No. All the cells will be sending unequal current to the external load in the same direction. No, see, try to please understand. ఈ కేసులో మీకు it is E only, but effective internal resistance is different. అది డిఫరెంట్ గా ఉంటుంది ఎఫెక్టివ్ ఇంటర్నల్ రెసిస్టెన్స్. ఆల్ ఆర్ ఆఫ్ సేమ్ సెల్స్ కదా, ఐడెంటికల్ సెల్స్ అంటే ఐడెంటికల్ ఇంటర్నల్ రెసిస్టెన్స్. మీకు గుర్తుందా E1 R2 plus E2 R1 by R1 plus R2 ఎఫెక్టివ్ EMF. ఓకే, ప్యారలల్ అయితే రెండు ప్యారలల్ అయితే R1 R2 by R1 plus R2 effective internal resistance parallel అయితే capital R. Right, what do you want? All the cells will be sending unequal currents to the external load. No, identical cells are not. So they should send equal currents. Unequal అయితే different currents.
Current zero EMF net zero. Reverse current.
అలా ఏం చెప్పలేదు. ఎన్టీఏ వాళ్ళ ప్రకారం ఏం చెప్పకపోతే నువ్వు కన్సిడర్ చేయాలి. దీని ఈక్వివలెంట్ ఏంటంటే చెప్తా. కాన్వెక్స్ లెన్స్ పవర్ ప్లస్ ప్లేన్ మిర్రర్ పవర్ 0 ప్లస్ కాన్వెక్స్ లెన్స్ పవర్ అంతే. 2 mu minus 1 2 mu minus 1 by r. కాన్కేవ్ మిర్రర్ లో నేనైతే ఇది చేస్తా. 2 mu minus 1 by r పవర్ 1 by f ఈక్వల్. ఓకే, నెక్స్ట్. Right. KQ by 2R plus Q minus 3Q by 2. So what is your answer? Earth to shell. Charge transferred is suppose if they are asking from shell to earth, you should say 3Q by 2. ఎక్కడ వేరే చోట ఉన్నా ఏ క్వశ్చన్ అప్పుడు పాయింట్ చార్ట్ ఉందా లేదు. ఒక్క నిమిషం. Outside the entire system, do you find any charge? Outside that system, you take a Gaussian sphere. What is that? That Gaussian sphere is enclosing the charge. There is a point charge outside. ఎక్కడ పొటెన్షియల్ 0 కావాలి? ఎఫ్ చేశాక సి దగ్గర పొటెన్షియల్ 0 కావాలి అనేటట్టుగా రీడిస్ట్రిబ్యూషన్ చేసుకుంటుంది. ఏది ఐసోలేటెడ్ కాదు. ఎర్లియర్ ఇట్ ఈస్ ఐసోలేటెడ్. నో, ఇట్ ఈస్ నాట్ ఐసోలేటెడ్. Connecting it here. You do whatever the distribution, finally the center of the shell, the entire shell is equipotential. 0. There is no field inside the shell, you know that. So when there is no field inside the shell, every point is equipotential. In fact, it is equipotential by volume. Every point inside the shell must be same potential as that of the earth. అదే మీరు నన్ను అడగచ్చు, why you favored in writing potential at sea? Why not some other point inside the shell? As you know, every point. But the problem is, due to the distribution of the charge outside, I cannot find potential at any other point apart from C. That is the reason why I am using point C as my reference. Irrespective whether it is distributed uniformly or non-uniformly, every elemental charge is equidistant from C. So therefore you can comfortably write the net charge on the shell into K by R as the potential contribution at the center. Any doubts? But still you are not convinced. Yes, come out. It seems that you are not convinced. నాన్న ఇందాక కేసు వేరు, ఈ కేసు వేరు. నేను చాలాసార్లు చెప్పాను, మళ్ళీ చెప్తున్నాను, ఎత్తరించి చేస్తే ఛార్జ్ 0 అవ్వాల్సిన అవసరం లేదు. పొటెన్షియల్ 0 అవుతుంది. సర్ఫేస్ మీద పొటెన్షియల్ 0. ఎస్. ఇప్పుడు లోపల అసలు ఫీల్డ్ లైన్స్ ఎక్కడైనా ఉందా? అప్పుడు లోపలంతా ఈ 0 అంటే dV by dr 0 అంటే ఈక్వి పొటెన్షియల్ బై వాల్యూమ్. And number 2, you question me why you are using C, and I have answered for that. Why I am using C as my reference point all the time? Because due to the charges on the shell, you can find potential easily at C. Any doubts?
On the shell, the potential 0 analysis. C on the shell, inside the shell.
ఇది మొత్తం వెళ్ళలేదురా.
అదే కేస్
వెళ్ళలేదురా. అరే, can you answer this? అది కూడా వెళ్ళా. I told just now, the entire portion will be equipotential volume. Equipotential surface is what you know. Equipotential by volume. Why? Surface potential is what you know. Okay. Just inside, electric field is 0. So dV by dx must be 0. Means you go inside, potential difference is 0. Means what is on the surface, it should be same just inside. Again, you imagine another concentric cell deep inside. You go like that. Every point you will see the potential same, which is as same as on the surface. Right. It's actually a pathfinder question. The question is like this. You do the arrangement. You have a thin conducting shell of radius r. And this is carrying And you know, at A, there is another charge Q, and at B, there is another charge Q. Now, the shell is earthed. All yours. Almost ఇదైతే అయిపోయింది. Which means I am assuming some X charge flowing to the earth. Can you please help me in writing what is going to be the net charge on the outer shell? Net charge. Please respond carefully. Net charge on outer shell. Yes, anyone?
Yes.
Wrong. What is the net charge now on the outer shell? Yes. What is your problem? Plus Q kadanda. There is an induced charge, a minus Q here. ఒక మాట చెప్పారు చాలా వన్ స్టెప్ సినిమా చూస్తారు ఇది అక్కడ దాకా చెప్పారు జస్ట్ నో ఆల్సో ఐ టాట్ డ్యూ టు పాయింట్ చార్జ్ క్యూ at A and due to the induced charge their combination contributes zero everywhere. And now you forget about it. Now you have two distributions, which means same as the previous question. Same as the previous question. Now, if we ignore that charge at A and that minus Q charge on the inner, the interior surface of the shell, ignore, this portion becomes same as the one which I have discussed. Now, what is going to happen? So, what is going to happen is that K times 2Q minus X by R plus K times 2Q by 2R is equal to 0. Why 0? Because you have connected it to here. Surface of this combination is 0, and hence every point inside C due to the contributions of 2Q minus X and 2Q will be 0. So with this 2Q minus X plus Q is equal to 0. So X is. So now tell me what is happening. A 3Q charge flows from the surface of the shell to earth. నేను ఎక్కడ మాట్లాడలేదు ఆ మాట. Show in the diagram. I shown the diagram. Any doubts? Pakka. What is the logic here? Charge at A. Induced charge on the inner surface. Together, potential is equal to 0. You know that? Rest everything is known to you.
ఇనిషియల్ చార్జ్ ఇనిషియల్ కి చార్జ్ కి ఇచ్చింది న్యూట్రల్
అవును,
అంటే
ఇనిషియల్ గా ఐసోలేటెడ్, ఇప్పుడు ఎర్త్. ఇప్పుడు మరి అవుట్ సైడ్ సర్ఫేస్ మైనస్ క్యూ ని కాంపెన్సేట్ చేయడానికి అడిషనల్ ప్లస్ క్యూ విల్ కమ్ అవుట్ సైడ్. Additionally, there is charge Q on the surface. Total is 2Q. Even in the first case also, even in this case also, outside surface, before connecting to earth also, you have 2Q charge. Why? Q minus Q plus Q. Additionally, you have Q. So total is 2Q. What is your doubt in the next part of the question? The moment I connect to S.
initially 2k charge like give minus 2k here and plus 2k then
ఎక్కడ
దీని దగ్గర సార్ అంటే
hold, I told you very clearly, charge at P 2Q will not induce minus 2Q. Because the entire flux at B is not depositing on to the shell, only a portion. So therefore it will introduce some minus Q dash nearby the face, near the face facing B. The farther face of B, it will have plus Q dash, but net is 0. Q dash minus Q dash induced by this one here is minus Q dash. This side it is a plus Q dash. Together it is 0. So now tell me what is the charge on the surface? 2Q initially. Now 2Q minus X. Any doubt?
Sir.
మైనస్ క్యూ వచ్చిందా? ఇండ్యూస్డ్. మరి దీని ప్లస్ క్యూ ఎక్కడ ఉండాలి? బట్ ఆల్రెడీ క్యారింగ్ ఏ చార్జ్ క్యూ అన్నా. సో టోటల్ చార్జ్ ఈస్ క్యూ. Otherwise, to avoid confusion,
inner surface content point charge at A.
they contribute 0 at every point. Every point.
Not only outside, inside also.
Yes. Why? I told you earlier. The charge center of the negative distribution exactly coincides at the positive.
So then minus Q which is reduced, the total means it will be at A point.
It focuses on A. Yes. Non-uniformly such that the charge center of that distribution falls at E. నెక్స్ట్ అది ఇదైతే అయిపోయింది. ఆల్రెడీ డిస్కస్. Most of the questions that I have discussed. Like center of mass. Okay. Exist కాదు. మ్యాథమెటికల్ గా నువ్వు ప్రూవ్ చేయగలవా నాన్ యూనిఫార్మ్ డిస్ట్రిబ్యూషన్ ఎందుకు జరుగుతుంది, ఎలా జరుగుతుంది? వై దే ఆర్ నాట్ కాంట్రిబ్యూటింగ్ పొటెన్షియల్ అవుట్ సైడ్? Because you can replace the entire negative charge distribution with one single negative charge, magnitude same, and it is placed at the same positive charge. Only then the net charge becomes zero, and that contributes zero outside. Right, 1 minute. Just everyone try to work on this question. So I think maximum of the models that I have covered related to electrostatics of conductor, basic models at least. Everyone try this. చేయట్లా ఇంకా సర్దుకుంటున్నా ఏదో. అదే కార్తికేయ is your name, right? చేస్తున్నావా? వెనక చివరి ముసుకోడు ఎవడు ఒకసారి పాప, రైట్. హాసిని, కే హాసిని. రైట్, మొదట యాక్టివ్గా లేరు అసలు. రికార్డింగ్స్ లో తేడా వస్తుంది. Don't tell me the answer. Yes. That's what your answer need to be. Minus q by 2. Should get minus q by 2. How many got this as your answer? Raise your hands. ఎందుకు చేయలా వచ్చిందా మహాలక్ష్మి వచ్చిందా ఆన్సర్ రైట్ 3 concentric conducting spherical shells A, B, and C of radii given A is to A for A, and they are having charges initially Q minus 2Q and plus Q respectively. The charges on the middle shall be B after switch S1, S2 closed simultaneously. Are S1, S2 closing in the sense you are starting and connecting. So according to me, the later part of the question will now become one single shell. I say that only one single shell, radius 2a, earthened with plus Q charge outside. You know how to find the charge on this part? Q. So KQ by 2a plus KQ by 4a is 0. Q is
Wait.
Q is right. A charge on the middle spherical shall be after all switches S1 and S2 simultaneously closed is minus Q by 2. What is your doubt?
Instead of having 3 concentrations, if we had 4 sir, and we have simultaneously attend the first 3 inside from inside.
You do whatever it is.
Yes.
As you are earthening 1, 2, 3, starting from deep inside, all will become a single cell because no charge will reside inside. On the very first class, I told fundamental point. What is the fundamental point? Charge cannot reside inside. It always be on the outer surface of the cup.
So that is the critical answer when S1 is closed.
Mm.
Here when S1 is closed.
Yeah, S1, S2 simultaneously.
Simultaneously.
Yes.
This case when S1 is closed.
No, both. Simultaneously closed means you shorted A and B and the combination is connected to earth. ఇది మళ్ళీ అడిగి ఒకసారి ఎస్ వెరీ గుడ్ క్వశ్చన్ నేనేమంటున్నా now this entire thing acts as one equipotential. You cannot have charge inside. ఎక్కడెక్కడ yes now this entire thing acts as an equipotential. If there is a charge here, right, see inside also earthened, outside also earthened, this is zero potential, this is zero potential, this is zero potential, everywhere inside it should be maintained zero potential. When is that possible? When dV by dr is 0. Means E should not exist. Means no charge. Right. Next question. I'm taking up another question. In this you can manage. Please confirm. Do we require to discuss this question? It's already available. Hold on. This is also done. Failing when multi operations are instructed. Stop. This is the final ultimate question. A spherical conductor of radius 2r, spherical cavity of radius r by 2. The cavity does not enclose the center of the sphere. Right. You can see charges Q1, Q2 are placed as shown. Q2 is at the center of cavity, and additionally Q3 is given to the sphere. The total charge of this system is Q1 plus Q2 plus Q3. Now work on the different options. Work on the different options. I think it's a manageable question. Basically, we have done. Now, see again, in my own style. Yeah, you please tell me. See this cavity and the Q2 and the inside part contributes nothing. So now what contributes potential is the potential by the outside charge Q1, and now I see the arrangement as simply I will see the arrangement simply as the conducting sphere and which carries a charge Q2 plus Q3 and whose radius is 2r, and you have a charge Q1 which is at a distance what is the potential at this point. That is the potential everywhere. So which is nothing but KQ1 by 3R plus KQ2 plus Q3 by 2R. Any doubt? Boys and girls. Mahalakshmi, are you sure about this? Next. Now, B is a challenge for you. B is a challenge for you. Very simple. See, everywhere in this volume, this is the potential. You know this. Now, what is the radius r by 2? This is some r. Can you please tell me about the potential at this point only due to Q2? Forget about rest of the system. Q2 minus a Q. You go outside, cancel. Undoubtedly. But this is the point inside. So already at this point, you have a potential of KQ1 by ER plus KQ2 plus Q3 by R got a 2R plus outside cavity, zero contribution. Inside KQ2 by small r minus KQ2 by R by 2. In this is due to the point charge and this is due to the shell. Any doubts? I don't want to explain anything. I simply said, in the absence of gravity, everywhere in this volume, potential is same. KQ in the material matrix. In the material matrix. But that is not material matrix. So there is a cavity part. Okay. And you come outside, they don't contribute anything. But you are inside now. Some flux lines are passing through you. So that contributes. అవును అది ఎప్పుడు బయటికి వెళ్ళినాం ఎక్కడ ఏ క్వశ్చన్ లో సార్ ఓకే వాట్ ఈస్ యువర్ ప్రాబ్లమ్ హియర్ ఇదే ఏమైపోయినాయి రవి Sorry.
Sir, ఇది ఆ ఫైల్ కి పేజ్ సార్ ఆ ఫైల్ ఉంటుంది ఆపరేషన్
సార్ రాశారు సార్ కిందకి వెళ్ళండి సార్